at is if we had like, if we have this region where it's the region bounded by those two curves. So we've got like a parabola and then we've got a straight line. What I had drawn last night on the diagram is a rectangle like this, where the thickness of the rectangle is dx. And the idea is that dx is basically getting infinitely thin. So it's basically like a segment. But we'll talk more about the significance of that later. But this we call a representative rectangle. And the reason we do that is because if I specify the x value for this rectangle, no matter where it is in this region, this rectangle would be able to get you all the information you need. Meaning that if I drew another one up here that goes from the top to the bottom, those are functionally the same thing. So like if this is at x equals, say, I don't know, so like if the x-axis is right here, or the y-axis is right here. So if this is at x equals -2 and this is x equals +3, then looking at either rectangle, just using a different x value would get us all the same answers. Does that make sense to everybody? Meaning like the top of the rectangle is on the line, no matter where I draw it in the region, and the bottom rectangle, or the bottom of the rectangle is on the parabola, no matter where I draw it in the region. So I could draw that red one, or I could draw that green one, and we would all get the same stuff, just as long as we specify the correct x value. Does that make sense to everybody? Everybody clear? Okay. And so what you'd like to do when we're doing area volume problems is we're going to have some sort of region drawn. We would like to be able to use one representative rectangle when possible. It's not always possible, but we want a rectangle that represents the entire region. And in this case, it does, because no matter where I draw it, the top boundary and the bottom boundary are the same. If I draw this region, where we have, again, a parabola, except I didn't draw it very well. Let's make it a little better looking. A little better. So we have a parabola, and then we have a line. This time, if I draw this rectangle and that rectangle, those are actually basically the same thing. Does everybody see that? Because the top boundary is on the same curve as the other one. The bottom boundary is on the same curve as the other one. The one over here, though, is actually different. Why? So somebody explain why that one's actually different from the other ones, even if I specify an x value.
Because it's attached to two different equations?
Yeah, so the top is attached to a different equation. So the top is on the line, whereas the top of these is on the parabola. The bottom's the same on all three of them, but the top is different. Does everybody see that, what I'm saying? Okay, we'd like to avoid that. If we can't avoid it, that's okay, and we'll talk about that. But you have to handle this with two separate regions, basically. You would have to say, okay, from here to the left is one region, and from here to the right is another region, if we set it up this way, because those are two different rectangles. Does that make sense, the idea? Okay, if we go the other way, though, so if I didn't use rectangles that go like that, if we go this way instead, now, no matter where I draw it, we're looking at the left boundary and the right boundary. As long as that's within the overlap, the left boundary is always on the parabola. Does everybody see that? The right boundary is always on the line. So that rectangle is functionally the same thing as this rectangle, but it's at a different y value. Does everybody get that idea? What I'm saying? Everybody clear? Okay, so we're going to put some informal terminology on this, where mathematically what we're saying, it doesn't actually make much sense. But if we look at a rectangle like this, where the base is dx, we're going to informally call that a vertical rectangle. Now, if we really think about it, vertical rectangle means nothing, but is everybody able to look at that and see why we would probably describe that as a vertical rectangle? Everybody understand what I'm saying? Okay, more specifically, the base of the rectangle is dx. That's the part that's getting infinitely thin, and that is a more precise definition. Does everybody get what I'm saying? But informally, we'll call that a vertical rectangle. So given that, what do you think we would call one like this? Again, informally.
A horizontal rectangle.
Horizontal rectangle. So we're going to call these horizontal rectangles. Again, there's nothing really that doesn't really mean much, but it does describe it pretty well. And this base now is dy. Does that make sense to everybody? Okay, and then one thing that's important to keep track of is that when you have a rectangle, we think of area as being like length times width, or the two sides as being length and width, or base and height. And so area we'll talk about later, but the dx or the dy, those are the base. And that means the height is the other way. So here the height is vertical. Here the height's horizontal, which is a little weird. But because we're saying dy is the base, we're going to describe the other side as the height. So the height's sideways when we're talking about one like this. Everybody get what I'm saying? Any questions so far? Good. Okay, so when you look at a region, if we can use a vertical rectangle that's the same over the entire region, then that region, it's preferable to use dx or to use a vertical rectangle. If we can use a horizontal rectangle instead and get the same rectangle the whole way, where it doesn't change, then it's usually preferable to use a dy rectangle or horizontal one. Sometimes both of them work, and sometimes neither of them work, where you can't do it with just one rectangle. Does that make sense to everybody what I'm saying? Okay, so I'm going to draw a few regions on the screen, and what I want you to do is try to figure out, okay, could we use a vertical rectangle and just have one rectangle that represents the whole region? Could we use a horizontal rectangle and have it represent the whole region? Do both of them work, or do neither one of them work? Does everybody get what I'm asking? So like up here, the one on the left, vertical would work, but horizontal would not work very well. On the right, vertical does not work very well, but horizontal does. All right, so if I'm drawing these, so let's say I've got all right, and so that's one of the regions. That's another region. And so let me divide the screen a little bit. Okay, and that's another reason I'm going to do a couple of them. And then here we're talking about that region. Okay, so I'll give you a minute to think about that, and then let's talk about it in just a minute. Okay, so let's look at it. So if we look at the one on the top left, would a vertical rectangle work well where the boundary does not change? So like if I draw in a vertical rectangle like this, is the top always on the same curve for that, no matter where it is in the region? Yes, the top is always on this parabola. is the bottom always on the same curve no matter where it is in this region? It is. This is probably a 4th degree polynomial or something bigger, but it's always going to be on this weird curve that's on the bottom. Does everybody see that? We sure that you get what I'm talking about on that? Okay, so like that rectangle is basically the same as this rectangle. You could draw the one on the right, I could draw the one on the left, and as long as we specify the x value, we would get all the same information. That make sense? Okay, left to right. So if we did a horizontal rectangle, does that work? Whoops. Does that work well on this region? It does not, because the left and right boundaries would be would change. And so if I draw a rectangle down here, it's like that. If I draw one up here, it's like that. The boundaries on those rectangles are different. It's not that that makes it impossible, but that makes it harder to deal with. Does that make sense to everybody? Clear? Okay, so we would prefer a vertical rectangle in this first region. On the second region, keep doing that. All right, on the second region, would a vertical rectangle work well? So like if I draw this here, is that functionally the same as if I draw it here? It is. The top is this horizontal line. The bottom is whatever this curve is. Does that make sense to everybody? Okay, so vertical rectangle works fine. Does a horizontal rectangle work well in this diagram? It also works fine. So the left to right, the left-hand boundary would be that vertical line on the left. The right-hand boundary would always be this curve. Does that make sense to everybody? We clear? Okay, so this one on the first one could be or should be vertical. The second one, both of them work well. On the third one, a vertical rectangle is a bad idea because this one is different from this one because the top boundary changes. Does everybody get what I mean? Okay, so the top boundary changes, we would like to avoid that. So we don't want to use a vertical rectangle. A horizontal rectangle, the boundaries do not change. So if I go left to right, the left boundary is always this line. The right boundary is always the parabola. So we would prefer a horizontal or a DY rectangle. Does everybody follow what I'm saying? All right, any questions so far? All right, and then I shaded it in green just to indicate what region I'm actually talking about here, but that's gonna erase more than I wanted. All right, so if I'm doing this one here, if I go up and down, then it's probably not a good idea because the top boundary changes. Now maybe this one's symmetric or something and we could deal with that later, but the top boundary changes. So in general, we'd like to avoid that. Does everybody see that? Okay, so if we can avoid that, let's do. If we go left to right, the boundary does not change. I'm just gonna leave that red one in there. And so if I go left to right, the left boundary is always the curve on the left. The right boundary is always the curve on the right, and we just stop here. Does that make sense? Okay, any questions so far on that? That's just something, when you draw the region, we want to think about that. And I had drawn a rectangle on the worksheet that you were working on last night, and it was representative of the whole region, meaning I just gave you a bunch of X values and it didn't matter as long as that X value was between the two intersection points. All right. Any
Wait,
questions?
so why on the bottom left I'm sorry, why on the bottom left drawing can you not do vertical rectangles, or you can, it's just not?
You can, but it's not ideal. And the reason why is because on like those two vertical rectangles, the boundaries are different. The bottom boundary is the same for both of them, but the top boundary is one curve over here and a separate curve.
Oh, okay.
You see what I'm saying?
Yeah.
That's what we're trying to avoid. And again, it's not like that's impossible to deal with. It's just later what would happen is you'll have two separate integrals to work. That's probably harder than just dealing with one. There are exceptions, but that's the idea. Does that make sense? Everybody clear?
Yeah.
Okay. And then another important thing to know is that if we do end up using the red ones, we would just have to divide this into two regions. We would have to go from here to here and do it as one problem, and then from here to here and do it as a second problem. And sometimes that might actually be better, but most of the time it's not, and it's just a good way to think about it. Does that make sense, everybody? Clear? Any other questions so far? All right. All right, so then I want to look at this. All right, so I want to say, okay, consider the region bounded by the curves y equals x squared plus 4 and y equals x plus 6. And so I want to draw that. So we should probably remember, okay, y equals x squared plus 4 is a parabola shifted up 4. So it looks like this. And then y equals x plus 6 is a line that has slope 1 and y-intercept 6. Do we remember that? All right, so slope 1 and y-intercept 6, which means it's going to do something like that. And it means we don't really care about this top left part. So I'm going to redraw that part. And so what we care about is the overlap. And so when you're doing diagrams like this, it's important to get one that's easy to look at as far as looking at the overlapping region. So like if you start drawing this and you get y equals x squared plus 4 looks like this, which is true, and y equals x plus 6 looks like that, and that's also true. Like that diagram's not wrong. It's just not useful. What we want to focus on is the overlapping part of the region. So it's really better. I mean, you need to be mostly accurate, but it's better to not be to scale and really be able to focus on this overlap than it is to be perfectly to scale and have a bunch of stuff that we don't need. Because what we care about is this. So if you start drawing the region like this, okay, but redraw so you're focusing on this and kind of exaggerate it so you can see, okay, well, this is coming down. So like the left boundary, if I was going to left to right, the left boundary would change, which is harder to see in a picture like this. Does everybody see what I'm saying? Everybody good? All right, so we want to get that picture. And so when I say consider the region, I mean, okay, let's get the picture. Let's figure out these intersection points. And so to do that here, we're going to set those equal to each other. Oops. So we're going to do x squared plus 4 equals x plus 6. And then we get x minus 2, x plus 1 equals 0. And I know I'm going quickly, but does anybody have any questions on that, what we're doing? Okay. And so that gets us 2, 8 here. And that gets us -1, 5 here. And I can figure that out by plugging the x into either of those equations, or actually both is probably smart to make sure that I've solved it right. All right, any questions on getting that picture? Okay. And so now which way would be a preferable rectangle? Would the rectangle be better if we went up and down or left to right, or would it not matter on this region?
Up or down?
Up and down. So if we draw one that goes up and down, the top boundary is always the line. The bottom boundary is always the parabola. The base of the rectangle is dx. Does that make sense? Okay, now look at all the stuff we did and look at what this problem asks us to do. So what like area or what volume or what have I actually asked us to find on this problem? So like we're getting into area volume. What volume are we looking for, or what area are we looking for?
In between the intersecting points.
We can find that, but what does this question actually ask? Like we
It
can
wants-
find it.
It
What's it
wants
say?
the whole area of
Does
the.
it? Does it? I mean, we can find the whole area, but what is this question asking you to find?
It doesn't ask anything.
It doesn't ask anything. Does everybody see that? It says consider the region, which means think about it. That's nice, but that's all it's asking. Does everybody see that? Okay, so consider the region just means, all right, well, we're thinking about it. The point is that we're going to be doing a bunch, starting tomorrow, we're going to be doing a bunch of area volume questions. And none of the stuff that we've done so far is contingent on what the problem actually asks you to do. It's contingent on the region. So when you're given the region, even if it doesn't say consider, you should automatically get a good picture of it, find all the boundaries. So like find these intersection points. If we don't label this boundary, we should at least know that it's 4, right? Because it's like x squared plus 4, that might be important. So you want to know these outer boundaries. So the right, the left, the bottom, and the top. This is the right and the top on this region. You want to figure out which way the rectangle goes, and then you want to figure out whether it's dx or dy based on that. So this is going to be a dx problem. Now, a couple things about it when it's dx. On this problem, I've already got everything solved for y, but anytime you're doing a dx problem, you need to solve everything for y. And if you're doing dy, you need to solve everything for x, whether that's what the problem gives you or not. Does that make sense? So I could easily have stated this problem, consider the region bounded by y equals x squared plus 4 and x minus y equals -6. And nothing would be different. The region would be the same, but we're going to want to think of this as y equals x plus 6. And we're going to want to think of this as y equals x squared plus 4, regardless of what this gave us. Does everybody get what I'm saying? We clear? Okay, so when it's a dx, solve for y. When it's a dy, solve for x. The reason for that is within any area volume problem, if it's going to be dx, you never get to use the letter y. You only get to write the letter x. If you want to talk about y, you have to describe it in terms of x. If you want to talk about x, you can actually say x. And so we're going to do some problems that aren't area volume yet, but I want us to find a formula for the distance from, and we're going to do 2 parts. A, the farther end of the rectangle, and B, and has an N in it, I think. B, the closer end to y equals 2 is going to be the first problem. All right, and so let's work this together. But what this is talking about is kind of what we were doing yesterday on the worksheet, but the generic formulas. So like what it was asking on the second set, like it would have you go through and do 4 numbers, you know what I'm talking about? So you do 4 numbers and then it would say, okay, what is it in general for X? And so that's what this is asking. So 2 separate problems. So part A is saying, okay, I want to know the distance from the farther end of the rectangle to y equals 2. Well, let's draw y equals 2 on there. That's a horizontal line right around there. Does that make sense? Okay, so if I look at the rectangle, which end of the rectangle is the farther end? The top of the rectangle or the bottom of the rectangle? On this one, the top happens to be farther away. Does that make sense? Okay, so when we're looking at the distance from the farther end to the line, we're looking for the distance from there to there. So is that distance vertical, horizontal, or something else? If I'm going from here to here. So from here to here, that's vertical. And we said yesterday, how do you do a vertical distance? Always.
The top minus bottom.
Yeah, the top y minus the bottom y. Does that make sense? Okay, so we're going to take the top y minus the bottom y. Well, the top y in terms of x is x plus 6. So the top y is x plus 6. The bottom y within that distance is what? So distance from here to here. So what's this bottom y value?
2.
2. So x plus 6 minus 2, which then simplifies to x plus 4. And again, the important part is what you're subtracting in what order, and then, okay, the simplification's easy. Does that make sense to everybody? I'm getting that? Okay, so you guys do part B. So the distance from the closer end of the rectangle to the line y equals 2. Okay. All right, and so this is now the distance from the closer end, so the bottom of the rectangle to like right there. And so again, that's a vertical distance. So we take the top y, but the top y is the bottom of the rectangle. So this is the top y, this is the bottom y. Top y is x squared plus 4. Bottom y is 2. And that simplifies to x squared plus 2. Does everybody follow that? Okay, we're going to call this function small r of x, and we'll talk about why we call it that tomorrow. We're going to call this function capital R of x. And again, we'll talk about why that is tomorrow, but and you don't need to remember that that's what they're called yet. We'll talk about this tomorrow. But is everybody clear how to come up with that? Everybody good? Any questions?
I'm sorry. Can you explain it again? I mean, how do I know where's the farthest end of the rectangle?
Okay,
Where's the
so
starting point?
you're good. So you're looking at y equals 2, right? Because it's the whichever end and then y equals 2. So looking at the diagram, which end of the rectangle is farther away from y equals 2? This end or this end? Which one's farther away from this line?
X plus,
The top
y,
of the rectangle.
y equals X.
Yeah, this is the one that's farther away from y equals 2.
Mhm.
But you want to
Okay,
look
so-
at the picture to determine that. Does that make sense?
Yes. Yeah. I get it.
Okay. And then the closer end of the rectangle happens to be this one. Clear? Is everybody clear on that? But that's for sure. So when you guys are doing area volume, if you've watched other videos or if you've read textbooks on this or if you've done it before, it may be explained in a different way, and that's okay. The problem is that a lot of times what people do is they try to figure out which equation up here to use, and you don't want to do that. You want to visualize these and say, okay, which end of this rectangle is farther away than y equals 2? Well, or from y equals 2. So you're looking at y equals 2. Well, look at it. It's either the bottom or the top. This one's farther away. And then because it's this one, then I'm using this. Does that make sense? Everybody clear? Okay, so I'm going to put a second one up, and I want you guys to try it. So y equals 15. And again, part A and B. So the distance from the farther end to the rectangle and from the farther end of the rectangle to this line. And then B is the closer end of the rectangle to this line. I'm going to give you like 2 minutes. I want you guys to really try it, and then we'll check it together in just a second. Okay. Okay, so I've written what I think it is on the screen. I want you guys to check what you have versus me and see if you agree. Is that what we're getting? And just be real careful. It's easy to get it backward. So like the farther end this time, so y equals 15 is up here now, right? So it's a horizontal line still, but it's above the region. So now the farther end happens to be the bottom of the rectangle. Does that make sense? Okay, so when we're looking at the distance from the line to the farther end, it's vertical, but the top y is 15, the bottom y is x squared plus 4 this time. Clear? And then the closer end of the rectangle happens to be the top because it's closer to y equals 15. So you take the top y, which is 15, minus the bottom y, but the bottom y is the top of the rectangle. So 15 minus x plus 6, you distribute and get negative x plus 9. Any questions on that? Please ask, because this is going to be stuff we're using a ton. And this is where volume problems typically get messed up, is doing these backward. Any questions? Okay. So what if it was y equals 1? So I don't want to work y equals 1, but y equals 1 would be a lot like which of these two problems?
Y equals 2.
Yeah, y equals 1 would be basically the same as y equals 2, except it'd be minus 1 each time. What about y equals 30? What would that be? It'd be like this one, right? Yeah, 30 minus each of those. What about y equals negative 6? So like if it's down here and it's negative, how would that be different? It'd be just like y equals 2, but instead of minus 2, it'd be minus negative 6. Does everybody get that? You clear? I want everybody to pause what you're doing for a second, look at the screen for a minute. Okay, just for a minute. So y equals negative 6 would be minus negative 6. What about the x-axis? So what if we said the closer end of the rectangle or the farther end of the rectangle to the x-axis? Then how would that, what's that more like? More like y equals 2 or more like y equals 15? If we're talking about the x-axis.
Y equals 2.
Yeah, y equals 2 because it's underneath the region. So instead of x plus 6 minus 2, what would you do for the x-axis? X plus 2 minus x plus 2 minus y. What would you do?
Just be x plus 6.
X plus 6 minus 0, which ends up being x plus 6. But yes, it'd be minus 0 because you're doing the top y minus the bottom y, and the y value there is 0. Does that make sense to everybody? We clear? Okay, so on the homework, some of them are going to say x-axis or y-axis, and when that is the case, something is 0. It may not be the first thing, but something's 0. Does that make sense? Okay, any questions so far? Okay. So that's for any horizontal line. Now I want to talk about vertical lines. So we'll get rid of these two. All right, and so problem 3 is x equals negative 4. So x equals negative 4 is over here somewhere. Does that make sense? Now read the problem real carefully and think about it real quick. And what's the issue with the problem I'm asking? There's something wrong with asking this. Something wrong with the question when it becomes x equals negative 4. What do you guys think?
You can't do a vertical distance with an x value. You have to have a y.
Okay, so we can't do a vertical distance. That's true. We need a y value if we're going to do vertical distances, but this isn't a vertical distance, right?
It'd be the same for both of them.
Yeah, okay. So part of it is it's not a vertical distance anymore, but when I'm asking farther or closer end, which end is closer to this?
X plus 6.
Not really, if we're looking at the rectangle, because it's infinitely thin. Do you guys see what I'm saying? So like this is parallel to this, so they're both equally as close. Both ends of the rectangle are. Does that make sense? Now, not the left and right of it, but dx in theory is infinitely thin, so there is no left and right, even though we're drawing it as though there is. Does everybody get what I'm saying? We clear? Okay, so rather than the farther or closer end of the rectangle, we're just going to say from the rectangle to the line. Okay, so instead of the farther and closer end, from the rectangle to the line, well, x equals negative 4. And so when we're doing that, we're talking about the distance from here to here. Is that distance vertical or horizontal? And we could be looking anywhere on the rectangle, but from there to there, what type of distance is that? Horizontal. Does that make sense? So when you do it, you take the right x minus the left x. Clear? Okay, but what is the right x? Is it x plus 6 or x squared plus 4 or something else? So if I, so last night I would have given you a number. So if I gave you that x was 1 here, and I wanted to know the distance from here to here, if this is x is 1, where do I plug in 1?
You don't have to.
You don't. Yeah, not only do you not have to, you should not. Because if you plug it in, those are giving you the y value. Does that make sense? So if I give you the x, you just use that. And you take this x minus negative 4. So that's the formula. It's x minus negative 4, which then simplifies to x plus 4, but it's x minus negative 4 to start out. Does that make sense to everybody? But it's just x. And in this case, we'll just call that r of x because there's no smaller or bigger. So we just call it r of x. We'll talk about why it's r later. All right, everybody clear? Okay, so I'm going to put 2 more on, and I would like you guys to try them. So number 4 is if I have x equals 7, and number 5 is if I have x equals negative 1. All right, and I'll give you just a minute to try those, and let's do this pretty fast. Okay, so we should be getting, for x equals 7, we should be getting 7 minus x. And the reason for that is that x equals 7 is a vertical line to the right of the region. So we're doing the distance from this line to this rectangle, that's horizontal. So you take the right x minus the left x. The right x is 7. The left x is just x. Does that make sense? Everybody good? Okay, and then x equals -1 is a vertical line. It happens to go right through this single point on the region. That's okay, because for any x in the region, this is going to be to the right of that still. So it's x minus -1. At the one value, -1, the formula is going to give you 0 as that distance, which it should, because if it's right on there, the distance should be 0. Does that make sense to everybody? Okay, so it's okay if it hits along the edge of the region. If it goes through the region, like down the middle of it, that's bad. And so we'd have to figure out how to deal with that later. But if it hits right on the edge, that's okay. You handle it like normal. Okay, any questions on those so far? You guys good? Okay, so if we have a rectangle in there, we should be able to get the distances to, like, if we think of this as a vertical rectangle, we think perpendicular line, so a horizontal line, we have a farther and closer distance. And then when it's parallel, if they're both vertical, then we do the right minus left in both cases. So right minus left, sometimes the rectangle's on the left, sometimes the rectangle's on the right. Does that make sense? Okay, last problem, or actually 2 more problems with this set. I forget what number are we? Number 6, I think. Number 6. So instead of find a formula for the distance from the rectangle, I want to know from one end of the rectangle to the other. Or actually, let's call this something else. Find a formula for the height of the rectangle. Let's say that. All right, so let's call that. So we want to find a formula for the height of the rectangle. Keep in mind, we're calling dx the base. So the height is the distance from the top of the rectangle to the bottom of the rectangle. Does that make sense? In this problem, is that distance vertical or horizontal?
Vertical.
It's vertical. So you take the top y minus the bottom y. Top y is x plus 6. Bottom y is x squared plus 4. So we get -x squared plus x plus 2. Does that make sense? Any questions on that? All right. Now, last question related to this. Okay. So set up an integral used to find the exact area of the region. So here's the way this works. When we're doing area volume problems, what we try to do is we try to set up a formula to find whatever it is we want for the single representative rectangle. Does that make sense to everybody? Okay, so I want to get a formula for the area of this rectangle. Well, in general, how do you find the area of any rectangle not involving a weird region like this? Just if I give you a rectangle, how do you find its area?
Length times width.
Length times width. And other words for that are base times height. Does that make sense to everybody? Okay, so length times width or base times height. So we're going to think, okay, well, area is base times height. So for one rectangle, the area would be the height of the rectangle times the base. Well, the height of the rectangle is what we just found. Does that make sense? Everybody clear? Okay, so the height of the rectangle would be negative x squared plus x plus 2. What is the base of this red rectangle up here? So the height's negative x squared plus x plus 2 because of this. What's the base?
Yeah.
Dx. So for one rectangle, it's that formula, the height, times dx. Does everybody follow that? We clear? Okay, now, so all right, so everybody just take a sec to look at the screen for a minute. But if I told you now that this, like what you were doing last night, is if I said, okay, this is where x is, say, 1.5. Okay, so this is the rectangle where x is 1.5. And then I told you what dx is. If I plug 1.5 into this, that would give me the height of the rectangle. And then dx, if that's like 0.1 or 0.2, that would give me the base. And I could plug those numbers in here and get the area. Does that make sense? If I told you this is at negative 0.7, I could do the same thing. I'd plug negative 0.7 in. It would give me the height, multiply by dx, and that would give me the area of that rectangle. Does everybody get that? Okay, well, the way integrals work is that then if I do the integral of this, negative x squared plus x plus 2 dx, it's going to add that up for whatever x's I want. Well, I want to use every x between negative 1 and positive 2. So the farthest to the left is negative 1. The farthest to the right is positive 2. And that's literally what this does, is it adds up every single rectangle within the region for every x. So not just negative 0.7 and not just 1.5. It's going to add it for negative 0.999998 and negative 0.999997 and negative 9.99 or negative 0.9996 and so on. It's going to add up every rectangle, and dx is going to get infinitely thin. We could write this as a Riemann sum, where that's literally what it is, and that's the definition of this. So it's saying, okay, add up height times base for every x in that region. Does that make sense? Questions? Okay, if we were to evaluate this, this is easier than a lot of the ones we were doing last week. Is that right? So we could easily evaluate that. Because I don't want to spend 7 hours on this, we're not going to evaluate that. But I want to talk about the next worksheet. Any questions so far? Okay, so I'm going to pull up this worksheet for a minute and talk to you guys about it. Give me 1 sec because I've got these weird share monitors going on. All right. Okay. Are you guys now seeing this worksheet? Distance scenario? Okay, cool. So what we're going to do on this worksheet, it's 4 pages, but it's basically 4 like what we just did, where you draw a region and then it's asking for a bunch of distances. So it's putting height first, which is the last one we did, and then the distance from like this line to the farther end and this line to the closer end. Does that make sense? Okay, so given that I'm calling these h of x, r of x, use dx on this page. Does that make sense? And then at the bottom, so okay, these are farther end, closer end for each of those. And then here, it's when it's parallel. So there's only one distance. There's no farther end or closer end. Does that make sense? And this is just coming up with the formulas like we were doing just now. Now set up an integral to use to find the area of the region. That's like what we just did. So the integral of the height, which would be the very top one, times dx. Does that make sense? And then I do want you to evaluate it and get a number. And that's actually how you find the area of the region. Does that make sense? Okay, and so it is 4 pages. There's 4 sets. I've given you the answers to pages 2 and 4, which I think are the harder ones to draw. So that's the reason I gave you those answers. It's worth it at some point between now and next week to make sure you are comfortable getting these regions set up on your own, because they're a little trickier. But you do have the answers, so you can check to make sure you're doing them right. And then I set it up. I didn't show my work on evaluating, but that's the answer when you get this set up. Does that make sense? Okay, so you have the answers to page 2 and 4. Some of them are dy regions. That flips everything. So like the height of this rectangle now is sideways. It's right minus left. Does that make sense? Okay, so height's going to be right minus left. The base is going to be dy. This is a lot of stuff, but try to do as much as you can before tomorrow, because basically in area volume problems, all you do is you find these and then you plug them into a formula. Tomorrow, we're going to talk about why the formulas are true, but everything you're finding on these worksheets, all these functions, this is what plugs into every area volume problem that we ever do. And we're actually done talking about area. Area is height times dx or height times dy. We'll summarize that tomorrow, but that's basically it. Okay? Any questions about that worksheet? So this is the other one you're going to hand in on CrowdMark. They emailed them both to you yesterday, and you can take pictures of your work. You don't have to print this out, and you do not have to recopy the problem. You can just write your answers. I'm just going to check to make sure you did it. Please do submit your work and not mine, so don't take a picture of my work, but you may, if you want, just copy my solutions down. That just won't help you very much on the test. Does that make sense? Use my solutions, make sure you're doing it right, but you know, it won't help you if you're just copying them. So if you're getting one wrong and you're not sure why, let me know and we'll go over that tomorrow. Okay? Any questions?
So all 4 pages are due on CrowdMark?
Yeah, so I made the 2nd and 4th page worthless because I gave you all the answers, but they are, I do want you to, at worst, you have to copy them in your own handwriting, but I think it would be better for you to try them. Does that make sense? All right. All right, but you don't have to do all 4 before tomorrow. Do as much as you have time for, because I understand how much work you guys have right now. So I'm in the same boat. We all have a ton of work right now. So do as much as you have time for, because this is the basis of everything tomorrow. Like tomorrow, it's just, we're going to go through, okay, what's the formula for volume, or what are these 2 formulas for volume? How do you pick which one to use? And then it's just doing this and plugging it in. Like the rest of it's easy. This is the main part. Does that make sense? Okay, other questions so far? Okay, I know a few people were interested in doing a graphing review. If you are interested in doing that, I'm talking about maybe like a half-hour session. We're not talking about a real long session. Stick around and we'll try to figure out the best time to do that. Regardless of whether you can come or not, I will record the graphing review and make it available to everybody. It's definitely not required. It's just something to help you if you want to do it. But we'll have lecture tomorrow, and then Friday will be optional. I mean, tomorrow's technically optional too, just you got to watch the video. Okay? If you have questions, stick around. If not, I will see you guys later. If you do want to do the graphing review, stick around. We'll figure out a good time for that. Thanks for coming, guys.